Inverter.
Welcome to clickmyproject.com. Now we discuss about the product Trademark image retrieval using synthetic feature for describing global shape and interior structure. Now we discuss the abstract for the process. A trademark image retrieval system is proposed in this work to deal with the vast number of trademark images in the trademark registration system. The proposed approach commences with the extraction of edges using canny edge detector, performs a shape normalization procedure, and then extract the global and local features. The global features capture the gross essence of the shapes, while the local feature describes the interior details of the trademarks. The two component feature matching strategy is used to measure the similarity between the query and database image. The performance of the proposed algorithm is compared against 4 other algorithms. With the rapid increase in the amount of registration trademark images around the world, trademark image retrieval has emerged to ensure that new trademarks do not repeat any of the vast number of trademark image stored in the trademark registration system. As the traditional classification of trademark image is based on their shape, feature and types of objects depicted by employing manually assigned codes, faults or slips may appear because of different subjective expression of the trademark images. Now we discuss the flow diagram for the process. At first the input image is taken from the dataset. After the input image is taken from the dataset, the input image is undergoing for the process of pre-processing. In this pre-processing step, we have to remove the noise from the image. So the filtering process is undertaken. In the filtering process, the Gaussian filter is used to remove the noise from the image. After the noise removal, the noise removed image is undertaken for the processing resize. After the resizing, the image is resized into an optimum size. Then the resizing, the edge is detected from the image. For the edge detection, we use the canny edge detection method to extract the edges from the image. After the edge detection, the centroid is calculated. The centroid is nothing but the center value of the image. The centroid value contains the two values. One thing is the x-axis and the y-axis. The xy coordinates depends on centroids. Then the feature is extracted from the image. The combination of two features such as local feature and the global feature extracted from the image are both combined together for the feature extraction step. After the feature extraction, the retrieval is undertaken. In the retrieval, according to the feature, the distance is calculated from the feature and then the respected image are retrieved. If the dataset contains the same relevant 10 images, means the retrieved image will be the 10. Now we discuss the initial running procedure for the process. At first, select the main_GUI.m file and right click in that file and select the third option, that is run. Now the initial GUI window was opened. In that you can see the several buttons known as the push buttons. These two axes are represented as an axis. Then this table is represented as an UI table. Now click the button input image. After clicking the button input image, the dataset folder will be opened. In that dataset folder, you can see the several images present in the dataset folder. Select any one image from the dataset folder and the selected image will be plotted in the axis 1 with the title input image. Then select the button pre-processing. After clicking the button pre-processing, the filtered image is shown in the axis 2 with the title filtered image. The filtering is done using the Gaussian filter. Then resize. After resizing the image will be resized into an optimum size with the title resized image. Then click the button edge detection. After the edge detection, the edge of the image will be shown in the axis 2 with the title edge detection using canny edge filter. Now click the button centroid. After clicking the button centroid, the edge of the object and the centroid is plotted. Now click the button feature. After clicking the button feature, the feature is extracted from the image and the extracted feature is shown in the UI table 1. Then the initial and decomposed image is shown and the DWT is used to convert the image into an wavelet. Then click the button retrieve. After clicking the button retrieve, the retrieved image is shown as an subplotted. There are 10 images relevant to the image which I have given as an input. Then the distance calculation is shown in the graph, that is a 3D graph bar chart. Thank you. This graph gives the values of the each distance. Then the x-axis represents the neighborhood index and the y-axis represents the neighborhood distance. The y-axis, if the major distance is occurred, then the bar chart will be large. Then the minimum distance will be occurred, then the bar chart will be the low value.